Record on this. Okay, we are now recording. So thank you for everyone on Zoom and watching. Let's turn the music off. Okay. Cool. So what are we going to talk about today? First, we'll give a quick introduction to what is REST. It's just one of the types of APIs. They talked a lot about that during the SSD workshop. And then we'll go into what is containerization, because that's basically what Docker is. We'll go into some basics of what Docker is. We'll do a quick kind of just like watch and learn demo of writing a Docker file. And then we'll jump into some of the cloud services, like the cloud computing side of this workshop. And we'll talk a little bit about like Kubernetes and Docker, Docker Compose, some of the other services that are used to like manage containers. And then the Google Cloud Run is the demo that we'll do at the very end. So we'll talk about what is Google Cloud Run in comparison to the other servers or the other services. So yeah, that I'll hand it over to Max.
Okay, so
I can manage the slides if you want.
okay, so first is just like the intro to REST and just APIs in general, in case you didn't attend the SSD meeting. Basically, just like to start simply, if you're downloading an app from the App Store that interacts with like a bunch of user data, say the Canvas app, right, which I'm sure we all use, you don't want to have to download the entire like database of like everything that Canvas stores, even just for like UF, onto your phone. And because obviously that would take a bunch of storage, right? And if you had to like update it, it would just be a really messy process. So instead, we obviously use the internet to communicate information between your device and the overall database. You basically can say like, okay, I want to get this information from the database, and the database will send it back to you, and then it can display it. And the way it does this is through HTTP, which I think stands for Hypertext Transfer Protocol. So it's basically just like, this is what's used to send requests from devices back to the database, and then obviously information back as well.
And you'll learn more about that in operating system, or is it operating systems, or maybe it's networking, but yeah.
Okay, so more specifically, a lot of times you'll have like these requests with certain headers, like here get. So if you're trying to pull up an assignment, it'll send a request to a database, and it'll be like, or I guess technically not a database. We'll get into that. Where it'll basically say like, oh, fetch me the information for this assignment. And so it'll say, okay, and it'll send you a little package of all the data that's needed for the assignment, which the app can then unpack and display to the user. So just very simple stuff. And then a REST API is used as basically a middleman between the two. So you can have it so that every single like outlet of Canvas, so it can be the app, it can be like the browser, or anything else you're using, it can all use this one REST API, which interacts with a database. And so, funnily enough, you can actually read the documentation for the Canvas API and use it yourself. My Shellhacks project, oh wow, look at the shirt I'm wearing, that's fitting, for this year, was actually using the Canvas API and making requests with like an external application on like one of our accounts in order to fetch course info. And it uses these like simple REST concepts. So again, you don't even have to do it. We did it with like, through like external software like Postman. You can literally like run these requests through your account, and like it will give you need access token.
Yeah, you can find your access token on Canvas settings, and then you can find it like and plug it in here, and then you can interact with Canvas through the browser.
And so there, what's happening is you're basically just querying the REST API that Canvas has set up here that can grab information from or just interact with the database in general. And so like,
question. Yes.
What does querying mean?
I mean, you can just think about like sending a request through the internet. So like every time that you type something in your browser, you're technically sending an HTTP request. And like when you type it in through the browser, it's a GET request. And then you can send different types of requests, which we'll get into in a moment. But yeah, just send a request through the internet. Just, like, in terms of how that's done, that's like a whole nother story with like routers and like different layers that you'll learn about in networking class. But yeah, just send a message through the internet. You know?
Okay, and so the actual like function of the REST API, it really just like connects the client with the everything that's in the database. Like I said before, you don't want the client to just always have the entire database itself. So the client, like no matter where it is, it can basically just ask for a specific portion of information from the database, or it can ask to like tweak a certain amount of information in the database, and the REST API will essentially funnel that through and make the changes itself. And there's acronyms for the REST API. Okay, yeah. And this is, I don't know, a little meme about like the interaction between the backend and the front end. They're both like pretty distinct parts, right? The front end is just like completely client side, whereas the backend, you'll never see it facing the client at all. So somehow you're going to have to interface those two together. And just like they did with, I don't even know how they attach these two bikes together. It looks like plastic wrap or something. I don't know. You can make REST APIs just as stable as that. Yeah, and so if you started to develop apps, you might be wondering like, okay, I have code that accesses the database, and I have a bunch of code in my front end. Why can't I just put the code to access the database in my front end? Like that seems like the easiest way to do it. And there's really just a variety of reasons. First is like security risks. Say if you had like the backend altering code on your like app, for instance, and a user changed the code of the app, they could do like anything that they wanted to with the backend, with all the data on your backend, which for many reasons is not what you want. Instead, if you have an API, there's really only like set routes that you can call through the API. So like since there's only like a set procedure of functions that the users can't change, that's the only things they can access. It doesn't matter how they interact with those things. It doesn't matter if they change the code. At the end of the day, it's going to be much more secure because there's nothing like they can't just like access like every single piece of data if they wanted to. Another thing is just increased server load. If you're making like a very, very large scale system, you don't want like requests from all these different places directly interfacing with the database all at once. It's better to have that all like coming through the API at once. You're not going to like overload your servers that way. If anything, you're going to overload your API, which is much safer. And then this last one, it's honestly just more difficult to maintain. We were talking about it, and Philip brought up a good point. Like if you're publishing something to the App Store, like we do with Clubfinity, you have to like put up a package, and then like Google or Apple has to like review that package, and then only then like it'll go up. If you have the code to interact with your database and it's wrong, good luck. You just wasted, a week or two or however long it takes, because then you have to wait for them. You have to tweak that code and then send it back up to the store or wherever you're hosting the file. But if you're using a REST API and you have code or you have to make changes to your backend, you can just change the API. That doesn't need to be redeployed because the front end is always just interfacing straight with the API. So as long as the like how you call the API doesn't change, you're fine. And so, yeah, like we mentioned here, like technically it's not something you could probably work around it if you wanted to. But as far as like just security and just like ease of use for large scale projects, like this is the way to go.
There's more reasons, but yeah, there's a reason why.
Yeah. What was this on?
Yeah, and then this is just to mention like there are different types of APIs. Like there's remote procedure calls, and then there's like SOAP. The only ones I've ever used are REST APIs and remote procedure calls, but REST APIs is what like the internet is built on. So whenever you send HTTP requests, that's most likely interacting with a REST API. And I think, yeah, you can keep talking about this if you want.
So like Philip mentioned and also kind of demonstrated before, the most simple request is just a GET request. This is when you're talking to a backend and you're essentially saying, okay, I want this piece of data that's already in the backend. And so obviously the database will just respond with whatever data that you're querying for, assuming you did everything correctly. But there's also other ways or other methods you can do with like headers, post, put, patch, delete, which for the most part, they're pretty straightforward, right? Post just adds some new data, delete removes that old data, and patch is like a replacement or an editing of the data. And honestly, you don't really need all these headers because like they're pretty much just flavor. You can like do some crazy stuff with like, or it's not even crazy. Like you could just say like at a certain route with certain parameters with like a GET request, you can make it so the database like deletes some data. But it's honestly just like way more straightforward for people to like edit and like read your code, first of all, and just to kind of interact with the API in general if you have a greater like variety in the calls you're offering. So once again, like this is the way, this is how it's done. And just like a bit of elaboration, this is like how you get things for HTTP. It's kind of mainly two parts. One's the route. So if you've worked with like APIs, you've probably seen this. If you go to like a certain like sub page, it'll try and like access a certain set of data. In this case, you're going to like /login because you're trying to send in like a login request. And then you can further kind of like specify what you want to do to the API by sending in parameters. Here, they're saying they're logging in with a username of Philip and password of 12345. Might want to change that. Yes. But you can literally like see how it's all like actually played out in the URL. And like if you're doing things nowadays, like you won't have to like type this stuff out manually when sending requests, but it is cool to see how it's literally like you can just type this into your browser and it will work. So
it's just like function parameters. It's just the way that you do it with HTTP requests.
Okay, and then we'll be transitioning to Docker. So how many of you guys have actually like heard of or used Docker before? Okay, a few. So the main premise of Docker is it allows you to run software on any hardware. So it's a tool that, given like a project with all like these unruly like packages and environments that you have to manage, like it's annoying to get that set up on a new like environment, right? So if you're trying to like install a large project from like a GitHub repo, let's say, maybe onto your computer or maybe onto a server, there's no guarantees that what worked for like the author of the repo will necessarily work on your computer, because you might run into all these like conflicts with the existing like environment variables, or maybe some things are not supported, and it just kind of can become a nightmare. So Docker guarantees that if you can get code running inside like the Docker container, it's guaranteed that you can get it running on any hardware, no matter what conflicts you would normally get.
Oops.
Yeah, and so this is me when I try to explain what Docker is. So instead, I'm gonna hand it over to Philip.
Okay, cool. Yeah, honestly, this is also me because Docker is really confusing, and it's kind of a hard problem to solve, like making sure that your software runs on any piece of hardware. And so Docker obviously worked really hard to make this easy for us, but it's an extremely complex process that I'm not really sure how it works, but I know like how to use it. I've used it for Clubfinity, and I've learned so much like on when it's useful. But yeah, so that's pretty much what I've used it the most for, is the project that we do, Clubfinity. But through that, I've been able to learn how to deploy simpler applications. But yeah, I'll try to like share what I know about Docker. So yeah, when I was preparing this workshop, I thought about like It says Docker is about containerization, but that sounds very similar to what a virtual machine is. So I don't know if you guys probably have heard of virtual machines before, but containerization is very similar to that. And again, allows software to run in any hardware environment. And it's a type of virtualization. So virtualization mimics the functions of physical hardware. So here you can see what a normal computer looks like. You have the hardware, then you have the operating system, and then you have application on top of that. But with a VM or just virtualization, you have the hardware, some sort of like manager where you can have multiple operating systems where each application thinks it has its own operating system. And yeah, so that allows you to basically have more isolation where each application thinks it has its own operating system and you have your own environment. And so technically you could run that environment on any hardware. So yeah. So that brings me to what is the difference between a virtual machine and a container? And that's just about the level of isolation. So it's about what the application thinks. How separate is this application from other applications you may be running on the same machine? So here you have traditional virtualization, which is just the virtual machine. And you see we have application, and then you have a VM running it like an entirely separate operating system. So you have 3 operating systems running on one hardware. Whereas on the microservices or containers, you have 3 applications running on one entire operating system. So these applications all think they're running their own operating system, but really it's, these guys are not. They're running the same operating system, and these ones each have their own operating system. And I'm getting too deep into the weeds because it's not really important to know all of this stuff. And you'll learn more about this when you get to operating systems. So yeah.
So why are we using containers? Like
Yes.
why?
Very good question. I think that might be answered on the next slide.
Oh, there you go.
Yes, good question. So yes, why? Because like they sound like they achieve kind of the same thing, but it's about the size and the speed and the purpose for which you do this. Like, if you want to run Windows, the entire Windows operating system on a Mac, that's a very like large task to do. That's going to require a lot of resources, and obviously you need like an entire new operating system running on this hardware. So that is something that is a very large task. So that would take a VM. But if you just want to run like a simple application, but you need to make sure that it runs the same on any environment, that's kind of overkill to have an entire operating system for this one application. So yeah, containers are fast to set up. They're lightweight and portable, whereas VMs, they have a high level of isolation because each process or each application has its own operating system, but they're obviously less lightweight and portable. So here you see we're running like Windows, Mac, that obviously could not be handled by a container, or maybe you could, I don't know, but.
So is this like something that video game companies do to run it on different platforms, like a single game, Mac? Linux?
I think yes, like it depends on the situation, because like you could probably with code you can do like literally anything. But for example, I think like with Google, for example, I think they have an operating system called Chrome OS. And when they want to run like Minecraft or something on there, they might run a whole VM on top of their computer to run that Minecraft. Because like I don't think Chrome OS like natively runs Java or whatever it is that's running Minecraft. So they might create a whole virtual machine to run that game. But maybe if it's a smaller game, maybe it's a container. So it's a good question, but yeah. Yeah, so then there's like this little analogy. Containers like a teleportation pod. Like you just instantaneously travel to your place, but you're in a cramped little pod. But a VM is like a private airplane. Take longer to get there, but it's more luxurious. And yeah, I think you guys understand the basic idea. VMs are just like big and bulky containers. You can easily send, we'll talk about images and all that soon, but you can easily send it to someone and then they can just spin it up and get a container running very quickly. and you can have multiple containers running very easily. They take up less resources, and yeah. Yeah, so containers are just lightweight VMs, basically, like kind of same thing, just level of isolation and how many resources they need. Okay, hand it over to Max.
Okay, so like as far as I kind of went into this before, but as far as like the actual purpose of using Docker, imagine you are developing an application that runs on Node version 19. Maybe this is like the most up-to-date version or whatever. And you're trying to set it up on this server that is only running Node version 12. Maybe it can't run Node version 19, or maybe there's some like other error, or it's just more difficult to install Node version 19. But either way, you have like this environment, the development environment, which has like all the up-to-date packages, and the environment's like configured in one way, and then you're trying to get Express to connect to an environment to the server where it's completely different. And so if you just try and maybe just like copy everything over, all the code over, it might not work on its own because certain dependencies might not work on that version of Node. And so instead, you kind of want some way to emulate having that version, the development version of Node, on the server. And this is what Docker can do by launching these containers. Hooray! And so, yeah, like I mentioned earlier, if you can get it on the host machine running on in like a Docker environment, then that container can be set up anywhere and it will run properly. So it doesn't matter where you're deploying it to, even if it's like some server that is like completely like way more annoying to work with than just the development environment. You get it working here, it can run anywhere. And it's also just way, way, way more easy to like install stuff from like big projects online. So if you're trying to like clone a repo, it can just be super annoying to get the correct environment set up. But if you just launch a Docker container that pretty much already has everything set up for you in the way that the developer intended, because that's the way that they do it. So it just makes working with large projects way, way easier. Okay, and so the main concepts of Docker, this is how like you actually can get a project set up and running across machines. The first thing you have to do is just write a Docker file, which then you can turn it into a Docker image and then a Docker container. On the next slide, there are kind of like, it's a better explanation of it. So the Docker file we will get into in the later slides. It's basically the blueprint of a house. It tells Docker what it needs to run in order to correctly set up the environment. So it's nothing like, it's essentially just like a text file with code in it, because all it's doing is it's planning out the foundations for the container. Then the image is after kind of, it follows the directions of the Docker file, right? It builds up that house and it gets this like functional environment, which you kind of spin off into these containers. So here we said the image is kind of like the demo house, because it is like this correct environment, but it's not actually being used for like living in this analogy. Whereas then you can create a container from that like fully formed image and then like actually run it on your servers. And so if you're actually going to be putting code into production, it's going to be running on these containers, which are cloned from the images. And so it's actually really simple. Once you have the Docker file set up, you just need to run Docker build to create it into an image. And then to get your code, like final code working, just run Docker run, and then you'll have your deployment instance. Yeah, it's basically the same thing. You just have to write a file and then build and run, and you're golden. And so these are the specifics here. It's almost very, very similar to like just setting up a development environment like by yourself. This is both Python and like Node, like pip and npm commands in case you need them. But it'll basically just like use Node take the packages, install all the packages, like place everything onto the container, like expose a port for stuff to interact with, and just start the application. Like you can see, it is honestly like it can be very, very simple because in the ideal environment, like all you need to do is just like install everything that's already put in like the requirements or packages. So here we have this like ideal environment, and we just need to tell it, okay, what fundamental things do we need to run in order to get this into a image?
Just want to mention one quick thing too, where you see where it says at the top from node latest. Also, I'm like shivering. It's like so cold in here. But anyways, that Docker maintains like many different types of base images, so that all you have to do is if you want to run a specific environment, you can go to like the Docker website and you can see all the different base images that they maintain. So there's like a Linux one. It's probably some sort of Mac or Windows base image. You see here, we're just using either like a Node or a Python based image, and they have probably different versions. So if you need a specific environment, you can just go there and trust that if it can run on that environment when you're like developing and testing, trust that it would work in a Docker container, because Docker works to maintain. You can think about it like the foundation for your house. You know that it's always going to be the same. So yeah.
Okay, and the only thing left to mention is environment variables. So when you have like the kind of demo house, as we mentioned earlier in the Docker image, how do we make it so that each container that we make is not just the exact same thing? We want, say we want to interface with two different databases, and we need each container to connect to a unique database. But there's no point in like rewriting all your code and making a completely new image when the functionality of the two containers should be the exact same. So instead, we use environment variables, and these are set like alongside the image when you're launching a container, and they basically just tweak. They're just variables which you can use in parts of your code that will say you can like do a link to a database in this instance that will be used in various parts of the code and effectively create different like actions in these containers when they're run. So like, for instance, in the Clubfinity app we work on, one environment variable we use is whether we are using like, or whether the app is connected to the production or development database. And so instead of just like, we don't need two completely separate like code like repositories for this stuff. No, all we need to do is just tell it like with one variable, one environment variable, yo, can I access the like real deal, or am I just like using the development database? And so, yeah, it's basically one, you can make small tweaks to your containers so you don't have to so you can be more efficient with your images.
Oh, yeah. I also added this because we'll talk more about this later on once we start talking about different services offered, but Docker Compose is another service offered by Docker. And it's does anyone here know what microservices are? What a microservice architecture is? Do you want to say it in your own words?
So Docker Compose, like if you have, let's say you have a few different REST APIs that make up your microservice architecture, like all your REST APIs need to work together to provide your service. You can spin up all those APIs in different containers, but you use Docker Compose to just do that all at the same time.
Yeah.
So it's like a Docker file that.
With more Docker files.
Yeah.
Yes.
Exactly.
Yeah. Yeah. Very like good explanation. So I don't know if everyone on Zoom heard that, but yeah, basically imagine you have multiple REST APIs. You can have multiple containers running that are connected together. So, you could probably just write multiple Docker files and then you deploy multiple Docker containers, but this would get very complex if you have like 20 containers. So you have a microservice architecture where you have one server that handles the database, and then one server that like listens for events from another website or something. And then another server for handling like socket connections so that people can like talk in real time. And you have another server for, I don't know, like a bunch of other ideas. But it's all one application. Whenever you want to deploy this one application, it'd be nice if you just like press one button, and that's what Docker Compose does. It just like scales up all of these containers. And so again, like you probably will never need this. So that's why we're not diving too deep into it, but like it's good to know. Like, it's good to come out of this workshop and like if someone says, do you know what Docker is? Do you know what Docker Compose is? And you have some idea of what this does. So we'll talk a little bit more about it in a bit. So, or I guess, yeah, this is basically what you were saying, where you have multiple REST APIs and you can just deploy all of them at once and you build up this huge infrastructure with one command. Okay, so now we'll talk about cloud computing because as Max was mentioning, Docker is kind of encouraged by these deployment tools. So you have Google Cloud, AWS, Microsoft Azure, and these other ones. So they kind of encourage Docker because it's easier for them to manage all their virtual machines and so on. So yeah, there is no cloud. It's just a server in some location. So they just call it the cloud because it's kind of like what it seems like. And yeah, this is just put here because it kind of shows you what are the largest cloud companies. I think AWS and Azure are the biggest. I've personally used Google the most, but I'm sure Jonas, who I think is on the call, I'm sure Jonas has used Oracle the most because he interned there. And yeah, I also have links to the services that they offer. Can you click on one of them? Because part of the reason we're doing this workshop is because it's a pretty confusing topic. Like, or no, wait, go back. Click on one of these.
Oh,
Yeah. Like each of these companies offer like hundreds of services, which is kind of wild. Like what do all these 100 products do? Yeah, so, and you can click on the other one for Google and Microsoft. Again, like hundreds of services. So we'll like briefly touch on what are some of these categories of services that they offer. When would you want to use some of them?
crazy.
Yeah, literally like hundreds of services. So the one I've used the most is Google Cloud, and mainly through Clubfinity. So when I started joining Clubfinity and learned how they deploy the application, we were using this Kubernetes engine. So you can see that's to deploy containers. But now we've moved to Cloud Run, which is like one layer above. So I found this image online and I kind of like it because it kind of layers the services offered in order of like the cheapest and most lightweight on the top, but then like the most powerful but most expensive down here. So, and you can see we have this word serverless. We'll talk about that more in a moment. But the reason we moved away from Kubernetes was because it's really complicated to deploy, and we were paying a little bit too much. So I think we had 2 servers, one for production, one for staging, and it was like $70 for the whole year for one of them. So 150 for the whole year for both of them. And like no one's really using it. So really, you know, it's like not a huge application. So we'll talk about why you would want to use Kubernetes in a moment. But Cloud Run is super easy to use. That's what we're going to demo at the end. And it spins up and spins back down depending on how many people are using it. So anyways, at the top, we have Cloud Functions. So that's a serverless service. So you don't have to like pay for a server to be running 24/7. Whereas here, this compute engine, it's a virtual machine. So you can literally like rent a physical virtual machine. I guess you can rent like a chunk of Google's computing power and you can just like run it 24/7. So, you know, you could just rent some computing power, run it 24/7, download all the dependencies for your application and just deploy it on that virtual machine. You could do that. But say that your application is only being used like 10 minutes a day. You know, then you're paying for like so many hours of unused computing power. So that's when a service like serverless would come into play, where if someone invokes your function or invokes your application, it'll spin up and then it starts running. And then once it stops running for like 5 minutes, it shuts off, and then you're not getting charged for that anymore. So then App Engine is a little bit closer to this like more powerful side of things, where I think with Cloud Functions, you can like you can literally define functions that get invoked individually. I think App Engine is where you can maybe have like one container. I think it's similar to Cloud Run. I've never used it, but with Cloud Run, you can just deploy a container, and then if the container is being called upon, then it starts up, you start getting charged, and then 5 minutes go by and it hasn't been used, the container shuts down, and then you're not getting charged anymore. Kubernetes is similar, but you can keep the container running like 24/7, and then Compute Engine is virtual machines. You can have a virtual machine running 24/7. So yeah, let's move on, because there's like a lot of details on this. With AWS, I'm just gonna highlight like what are the, corresponding, like what do the different services kind of correlate to? So you have AWS Lambda. Does anyone know what a Lambda function is? Do you wanna?
You said you just like little application.
Yeah. But like a Lambda function in like programming,
Oh, yeah.
yeah, so that's kind of like what it is. It sounds similar. Like I think it's just like a marketing thing, like to call it Lambda, because it's kind of similar to a Lambda function.
Yeah.
Yeah. So yeah. So then Elastic Beanstalk, we're gonna share these slides later on. So if you ever have like an idea for an application, you can reference these and like see what is ideal for your application. Or there's probably more in-depth resources online, but this just gives you an idea. Where has anyone ever used EC2 before? No. Basically, that's just like you rent a virtual machine and you can SSH into it, and you basically have your own computer. Yeah. Yeah, you can rent a Linux server. Exactly. So same thing. And yeah, they have this Amazon EKS, which is comparable to the Cloud Run. Or no, that's for Kubernetes, which we'll cover in a second. But Amazon Elastic Container Service, that's like comparable to Google Cloud Run. Okay. Azure I've never used before, but I know it's bigger than Google Cloud. So I just have never used it myself. But yeah, we keep seeing this word Kubernetes. So I think that's the next slide. Oh no, okay. Yeah, serverless, like, is it really no servers? It's really there are obviously servers, like you can't run code without a machine. So basically they have these servers that can scale up and scale down very easily. So if code is not being used, then they just like turn off that piece of code, I guess, and then you don't get charged for it. But it's still a server running all these individual Lambda functions or whatever they call it. So yeah, some like benefits, like why would you want to use it? Serverless is really easy to use, it's cost effective, and it's simplified operations. But the drawbacks are debugging. In my experience, now that I've used Google Cloud Run, which is not serverless, but it's like closer to it, it's like the way the access into like the logs, you have less power, like you can't see everything that's going on as clearly. I don't know about security and vendor limitations, but yeah, maybe that's a drawback. I don't know about that, but with response latency, I've definitely noticed that. So like I deployed something with Cloud Run, and I noticed that the first time I ever call that API, it'll take like a few seconds, probably because it's spinning up. So you notice it significantly, where it's like loading and loading. I feel like with applications, like seconds feels like forever. So, but after that first initial like loading, then it's like in milliseconds because it's already running. So I have noticed it, and maybe there is latency beyond that, like not just the initial run, like initial load, but that's just what I've noticed. Yeah. Okay, so talk about a little bit about Kubernetes. So it's an open source container orchestration system. And basically you're just managing multiple containers, which sounds very similar to Docker Compose, but Kubernetes is more for scaling up. So if you have a server that, let's just use the example of Docker Compose. Say you have a server that has or an application that has multiple containers, maybe 3 containers, one for the database, one for like socket connections, and one for listening to outside events. It's one application, it's 3 containers. But then say you start getting so much traffic, people just start using your application for some reason. And your one like instance of this application is not able to meet the demands. You can use a service like Kubernetes to create like different copies of these applications. So then you can have like a load balancer distribute the request to these different versions of your application. Well, yeah, so that's basically what that is. We'll go to the next slide. Yeah, it's just like takes control of your application. It's really hard to set up, but it's really powerful if you have an application that needs to scale up and scale down very flexibly. So I want to talk a little bit about like why it's kind of confusing. So you have this Kubernetes cluster, and then you can have multiple clusters. Within the cluster, you have like this node, and you have a master and like the node process and all that. But it's not too important. Just think about it, the node. And then the node can have multiple pods, and then each of those pods can have multiple containers. So like that's pretty confusing, but it just shows you that it's very powerful. But on the next slide, you'll see, do you even need it? Because if you think about it, a single node application can handle 15,000 requests per second. So most likely any application we're building, one node server is probably enough. You don't need pods and multiple clusters and multiple nodes. Like that's overkill. And that's why we moved away from Kubernetes, because we're probably not getting 15,000 requests per second. So one container is likely fine for your purposes. And sometimes you might not even need Docker. Like if it's just a simple application, you could maybe just get a VM. You can find cheap VMs, just SSH into your VM, install your dependencies, and just like deploy it, like expose that application from your VM. But these are just options that you might have, and like they're buzzwords in the industry. So it's just nice to have an idea of what Kubernetes is. So yeah.
Kubernetes?
Yeah. And yeah, more memes. Kubernetes is really confusing. Like the nodes and the setting up the kubectl clusters and all that. And yeah, they kind of does like the same thing as virtual machine, just like multiple containers. So yeah. Oh, okay. So yeah, in terms of Kubernetes versus Docker Compose, Kubernetes is kind of like for large scale applications that require like apparently like tens and tens of thousands of requests per second. Then you probably would need something like Kubernetes. But Docker Compose, you can think of it just like for simpler applications that maybe they don't have that many requests per second. But pretty sure you can have Docker Compose and Kubernetes at the same time, because Compose is very useful if you start having to deal with multiple containers for a single application. And yeah, I guess so. Compose is for multiple containers on a single computer for smaller deployments. Kubernetes is for multiple containers deployed across multiple computers. Larger deployments that require scaling up and down. So, okay. Hopefully we didn't lose you guys, but we have the demo now. Does anyone have any questions so far? If not, we can
Send this in Discord, the guide doc.
yeah, send in the Discord. So yes.
This may be a silly question, but like, is Docker, I guess, owned by a certain company and do they charge for it in a way, or is it like separate?
Yeah, that's a good question. They are a company. But I don't know how they make money because they offer their services for free. I think you can buy like packages, and they're obviously supported by the companies that use them.
If I wanted to just like mess with Docker, and like maybe deploy a couple containers on my computer just for like an assignment for networking pop up. Would it be better just to use like literally just use a VM, like how we do it in like operating systems, or would it just be better? Would it be kind of interesting to use it as a Docker file? Like,
Sorry, I'll get back to that in a second, but apparently they charge companies a per seat subscription. I'm guessing if there's a company that's making a lot of money through the Docker services, they'll charge them some money. So like, what is the purpose again?
so, yeah, I guess it's for like, if I were to just use it for like a personal project, maybe not even like Infinity, would it be better to just run multiple VMs on my computer, like, or what should I try to use Docker and like, what do you do?
I mean, the reason why I would think it's nice to learn Docker is because it kind of makes it more repeatable. Like if you ever want to deploy this project down the line, you can,
If
Would-
we ever share it with our teammates, it'd be pretty good.
Yeah, in that case, yes, yeah.
If they just come back, I think it runs through.
Yeah, like I don't know what like platform you're using or like what dependencies you're using, but like if you have someone who has a Mac or a Mac Intel or Mac M1, I've experienced it where it's like there's an npm package that works fine for me. I feel like we experienced it, me and you, where like you're trying to run Clubfinity and then it doesn't work on your computer for some reason. But if you containerize it, then you just download Docker and you can trust that. Yeah, it worked on my container, so it should work on your container theoretically. So
Okay, so like,
I don't know if that answers your question.
Senior project planning?
no, it's more like, the simple, I'm networking right now.
Okay.
And I was like, okay, maybe instead of going to the Linux freaking computer lab every time, I thought maybe it can be kind of fun to make a little container, like maybe multiple containers and run networking applications again.
Yeah. That would make more sense. Yeah, because each process could be like each container is like talking to each other.
Yeah, yeah. So I was wondering if it would be better to use a proper container or just like try to hack him or something.
Yeah, maybe it might be quicker than doing a whole bunch of VMs, you know.
Okay.
And if you could use like Docker Compose to spin up a bunch of them and like it would be interesting. I don't know if
So the Docker Compose instead of a bunch of like, containers and the exact.
Yeah.
I would assume like Compose is more like if you have like multiple different containers, this is gonna be the same like type of container, just what maybe you're running at the same time.
yeah, I've never used Compose myself. I've just like I know what it yeah.
Okay, gotcha. All right, cool. That's about, I just wanted to spend myself.
Yeah. Is there another question here? Or oh yeah, true. I think it's a whale. Yeah. I think that's just for the compose command. Like
Okay.
that's yeah. Okay. Okay, so
Yeah, what is it with like GitHub has like the octopus as well? There's a lot of like everything's like very like nautical themed.
I think I'll just join the Zoom call. We're running low on time. So
Yeah,
it's just a very quick demo. So I just want to show you guys the Google Cloud Run is on like that lower end where it's cheaper and easier to use. So I just wanted to show you how easy it is to use. Like we have this REST API that we've deployed on GitHub.
Did you want to share your screen in the Meet or hook it up with like HDMI or what?
I'll just share my screen on there. Can you? Okay. So
Hold up, let me.
can you put my,
Yes, sir.
okay, nice. So we have on the slides that we're gonna share, it links to this GitHub Docker workshop. And if you went to the SSD workshop, you'll know pretty much what is happening here. Basically, we just have an Express application that's just returning random dog facts. And if you don't know what's going on, this is probably a good introduction to Express and REST APIs. But it's just basically a route and it just returns, the default route just returns hello world. And then otherwise returns a random fact, generates a random number. and it picks a random fact from this list of facts. Or you can specify the fact. So right now I've deployed it already. So if I go to this, we get the application. So I'll do random and we get a random dog fact. So just for the sake of the demonstration, I'll change this first fact to I love Docker. And I think we have the guide somewhere. Where's the guide? Here. On the slides, we at the very bottom, we link to the guide and also the GitHub. So this is the guide that is linked to it. And it walks you through the steps of logging into Google Cloud, setting up Google Cloud Run, also like deploying the Docker container. So yeah, you'd have to just basically download Docker and then you can clone the repository and follow along. So the first step is Docker build, like what Max was saying. So we have this server that we can run locally. So we just do Docker build. And we specify the tag, which is my Docker image. Right now it's turning this server, which we have a Docker file defined here. It's like, I think it's the exact same thing that we showed in the slides. We're just making a Docker image. So boom, it's done. And I think I have Docker installed and running. So this is like a nice GUI that they offer. You can see it just pushed a new image 1 second ago. So now we'll go back to the server for the guide. And now we'll turn this image into a running container. So just do Docker run, specify the ports. And now it's listening on port 8080. So if I go to localhost 8080 random, we get a random dog fact. I think if I do, we get our index 0 for the fact that we just defined. I love Docker. So go back to the guide. So that this is containerizing the server and then running it locally. But obviously what we want to do is deploy the container. So you just follow these steps. You can sign up for a free trial for like 3 months and like $300 worth of computing power. And then you enable the container registry so you can push containers to this like database of containers within your Google Cloud account. Then you create a service account so that you can like authenticate to Google. Then you will create some keys so that you can, a bunch of mundane steps. I don't want to do all that with you right now. So now we'll run the same thing again. We're going to build the Docker container because now we want to deploy it to Google, right? So I'll stop the container. Stop it. And so now we're going to build a new image, but this new image is different from the first image we built because now it has like the Google Cloud project ID here. So you can get that from here. Oops. So now it knows where to put this Docker image. I think so once we push it to Google Cloud, it knows where to go, like what directory it should be under. Because it's kind of like all of VM. So it's like where in this VM should it go? And then go back to the thing here. So now we'll push it. Now we'll do Docker push. And my computer is like getting so slow because it's Docker running and Zoom. So go back to here. So now Docker push is like slightly different from what we taught before, but it's just deploying it to a new location. So once this is done, we should have a container in our Google Cloud account. I guess no tag. Okay, so it's deploying this. And we're almost there. There's like literally one more step and then it's done.
Is the, I guess the container. Or this JavaScript file, like the backend, quote unquote.
Yeah,
Okay, the container that would run that. Or it would act as that backend server.
yes,
Which is running that code.
yes, exactly. So now. Okay, it's like my computer's so slow, but basically you go to Cloud Run, click create a service, and then you should have your image right here, which is what we just pushed to the cloud service. And then you literally just press create, and then boom, you have a URL for your container image. So you can see like it's literally a few steps. So if you wanted to deploy a REST API, Cloud Run is designed to be extremely easy to use. So yeah, that's pretty much it. Like I think we might be able to deploy it, but it's 6:32, so I don't want to keep you guys longer than. But here it is, 1 minute ago, deployed. So you just click select. Apparently we already have this, so we'll just make a new one. Allow unauthenticated invocations, and boom, that's it. So now you know how to deploy a Docker container with Cloud Run. So that's it.
So now on any computer, you could just send a network request to the.
Yes, on any computer, like you can route this. Yeah, like this is a URL that anyone on the internet can access because Cloud Run offers, yeah.
Yeah.
So.
Good, it just does all that like, DNS networking.
Yeah, exactly.
Deploy onto the cloud.
Yeah.
And look, it already deployed. We already have it up,
Yeah.
which is crazy that it.
It's so like, you would ideally have two containers, one would be a REST. Well, I guess you would have two.
Yeah.
One would be the REST API and one would be the backend. And so you said you change the backend. And everything you was change.
Wait.
Like, let me see.
I need to back up.
Yeah.
Yeah, like you see, that's on the internet, like anyone can access that.
Precisely.
Okay. All right, if you guys have questions, stick around.
I like that we started and ended the workshop complaining about Apple products.
All right.
Oh, yeah.
Thank you, everyone online.
Hope
Hope you enjoyed the workshop. Bye bye, Sir Rob.
We're trying to do it every Wednesday, but we should have one next Wednesday. We're trying, yeah.